Objective in inscribed solids. First, to recognize and find measures of inscribed solid. Second, to find properties of inscribed solid.
The objectives of circumscribed solids. To help you assess how the students are able to use geometric properties to solve a problem. It will help you to identify and to help a student who has difficulties decomposing complex shape into simpler one in order to solve a problem. It will help you to identify and to help a student who have difficulties bringing together several geometric concepts to solve a problem. It will help you to identify and to help a student who have difficulties finding a relationship between inscribed and circumscribed circle or right triangles.
About 2200 years ago, the famous Greek mathematician, physicist, and inventor Archimedes of Syracuse showed that the volume of a sphere or radius contained in a right cylinder of the same radius and height just equals 2/3 of the volume of the cylinder. Also, among Archimedes' most famous work is the measurement of the circle, in which he determined the exact value of pi and the values of 3 and 10/71 and 3 and 1/7. Thus, he obtained by circumscribing and inscribing a circle with a polygon having 96 sides. However, he required the proof of the two fundamental relations between the perimeter and area of the inscribed and circumscribed regular polygons. He was so proud of this discovery, which preceded calculus by 2 millenniums, that he have a grave marker put on his final resting place, consisting of a column topped with a cylinder containing a solid sphere.
Hi guys, this is my explanation and example about inscribed and circumscribed. The inscribed figure is a shape drawn inside another shape, and a circumscribed is a shape drawn outside another shape. For a polygon to be inscribed inside a circle, all of its corners, also known as vertices, and it must touch the circle. And also inscribed polygon, it is a polygon in which all vertices lie on a circle. And circumscribed polygon is a polygon in which each side is tangent to a circle. This is my example in inscribed. And first example is you need to draw a triangle like that and find the center of the triangle and draw a circle that fits in a triangle like that. Example of inscribed. And for the example of circumscribed, to make it easy, first you need to draw a circle and draw a triangle inside the circle to make it circumscribed. That's all.
Hi guys, today we're going to talk about the inscribed. Let's think about two figures like a polygon and a circle. You can say that a polygon is inscribed in a circle. For one thing, you could think of it as being inside of the circle. But technically, a polygon is inscribed in a circle if all of its vertices are on a circle. The same thing in solids like prisms. Thank you.
Good morning guys, I'm here in front of you to explain what is inscribed solid. An inscribed solid is a place inside other solid with the edge of the two solid touching. The figure below are from the left to right: a cylinder inscribed, a sphere inscribed in a cube, and rectangular solid inscribed in a sphere.
Another example of circumscribed shape are circumscribed pentagon, circumscribed angle, circumscribed quadrilateral, circumscribed hexagon, circumscribed rectangle, and many more. The circumscribed pentagon is pentagon drawn outside of any other shape. It must be touching all the vertices if available. Pentagon can be regular or irregular. The circumscribed angle is drawn with the arm of the angle, touch the circle as the tangent are drawn to the circle. The circumscribed quadrilateral is quadrilateral drawn outside of any other shape. It must be touching all the vertices if available. The circumscribed hexagon is hexagon drawn outside of any other shape. It must be touching all the vertices if available. The circumscribed rectangle is the rectangle drawn outside of any other shape. It must be touching all the vertices if available.
Now let's proceed on circumscribed solid. What is circumscribed solid? According to Merriam-Webster, circumscribe or circumscribing, it is to construct or be constructed around a geometrical figure so as to touch as many points as possible. So any figure that circumscribe any other figure, it means to draw outside another figure. But the circumscribing figure must touch all the vertices of the inside figure. For an example, in a circle, circumscribed pentagon is must touch all the 5 vertices of the pentagon.
The importance of inscribed. The measure of each inscribed angle is exactly half the measure of its intercepted arc. Since they have the same intercepted arc, they have the same measure. Therefore, the measure of angle must be half of 180 or 90 degrees. In other words, angle is a right angle. So, always remember that the measure of the inscribed angle is half of its intercepted arc. If a quadrilateral is inscribed in the circle, the opposite angles are supplementary. If an angle is inscribed in the semicircle, then it is a right angle, and that is the importance.
The importance of circumscribed solids. We use circumscribed solids for many reasons, including engineering and calculations of perspectives. And as I noticed, most of the word problems about circumscribed solids that I found on the internet doesn't have drawing in it. So we have and need to visualize and assess the problems, to identify and draw the shapes that is given, so that we could easily understand and know what geometric properties we will use to solve the circumscribed solid problem. That is why the importance of circumscribed solid is that we will learn to visualize and improve our problem-solving skills.
Let us define a prism is inscribed in a cylinder. As you can see in the figure, a regular right pentagonal prism is inscribed in a right circular cylinder where the bases of the cylinder and the lateral edges of the prism are touching the curved lateral surface of the cylinder. So things to know, if a prism whose bases are regular polygons is inscribed in or circumscribed about a right circular cylinder, and if the number of lateral faces is indefinitely increased, the following limiting concepts will occur. First, the volume of the prism approaches the volume of the cylinder as a limit. Second, the area of a cross-section parallel to the bases of the prism approaches the area of a cross-section parallel to the bases of the cylinder as a limit. Lastly, the lateral area of the prism approaches the lateral area of the cylinder as a limit. So that could be my report for today. Thank you.
Prism is circumscribed about cylinder. The bases of the prism are circumscribed about the bases of the cylinder, and the lateral faces of the prism are tangent to the lateral surface of the cylinder. If the number of lateral faces or sides of the prism is increased, the space between these two solids will decrease.
Hi everyone, I'm here to explain how to solve the prism is circumscribed about a cylinder. Let V be the volume of the cylinder and T be the total area of the cylinder. To solve the volume of the cylinder, we take note that the diameter of the cylinder is equals to the edge of the cube, and the height of the cylinder is equals to the edge of the cube. Now solving for the volume and total area of the cylinder circumscribed in a cube of 8 cm. The formula is volume equals area of the base times height. The formula for the volume of the cylinder can be as pi times radius squared times height, which equals to pi times 4 centimeters squared times 8 centimeters is equals to 128 pi cubic centimeters. And for the solving for the total area, we have total area equals lateral area plus 2b equals 2 pi times 4 centimeter times 8 centimeter plus pi times 4 centimeters squared equals 64 pi plus 16 pi centimeters squared, which simplifies to 80 pi centimeters squared. Therefore, the total area is 80 pi square centimeter.
The definition of pyramid is inscribed in a cone. If a pyramid whose base is a regular polygon is inscribed in or circumscribed about the circle cone, and if the number of sides of the base of the pyramid is indefinitely increased, the volume of cone is the limit of the volume of the pyramid, and the literal area of the cone is the limit of the literal area of the pyramid.
This is how to solve a pyramid is inscribed in a cone. For example, a pyramid is inscribed in a cone whose square base has sides of length of 8. The height of the cone is 6. Then, find the volume of the cone. To find the volume of a cone, we must use the formula V is equal to quantity 1/3 pi RH. Next, substitute the value into the formula. So V is equal to quantity 1/3 multiplied by 4 squared multiplied by 6, because the radius of a circle is half of the length of a side of a square. Then we get the answer of V is equal to quantity 96/3 pi. Then simplify to get the answer. So the answer is V is equal to 32 pi. The definition of the pyramid is circumscribed about a cone.
If the pyramid be circumscribed about a cone, the surface of the pyramid, excluding its base, is equal to a triangle having its base equal to a perimeter of the base of the pyramid, and its height is equal to the side of the cone. The base of the pyramid is a polygon perpendicular about circular base of the cone, and the line joining the apex of the cone or pyramid to the point of contact of any side of the polygon perpendicular to that side. All of these perpendiculars being generators of the cone are equal. Hence, the propositions follows immediately.
Volume of a cone and pyramid. Here's the formula. Volume equals to 1/3 times area of base times height. So, the pyramid, we put the pyramid in the box. The area of base equals to 8, and the height is 10, and the radius is 4. So, here, volume equals to 1/3, 64. The area of base is 8, so 8 times 8 equals to 64. The height is 10, so we put it 10. Volume equals to 1/3 times 64 times 10, and that can be give your volume and give the units of cube. So next is cone. They're the same shape but not the same area of base. So the formula is volume equals to 1/3 pi r squared times height. So volume equals to 1/3 pi the radius is 5, so 5 times 5 equals to 25, and the height is 10. So this is a fraction, so we think a whole number to make this fraction. So we put this a 1, 1, and 1. So we multiply the numerators and the denominators. So here equals to 250 pi over 2, 3. So, this is the answer.
Once again, thank you for watching. We hope that you have learned a lot in our group discussion.